Hey everyone, welcome back to BugNoJutsu, where we break down coding problems with ninja-level clarity. In today's video, we're solving LeetCode 3201, find the maximum length of valid subsequence I. It's a medium-level problem that tests how well you can identify parity patterns within arrays. Let's dive in, and by the end of this video, you'll not only crack the problem but gain deep insight into parity-based patterns for subsequences. You're given an array of integers called nums. We need to find the maximum length of a subsequence that is considered valid. But what's a valid subsequence? A subsequence is valid if all adjacent elements in it have the same a plus b %2 value. In simpler terms, if the sum of the first two elements is even, then every adjacent pair after that must also have an even sum. If the sum is odd, then every adjacent pair must have an odd sum too. And remember, a subsequence means we can skip elements, but we must keep the order. In this example, we are given the array 1, 2, 3, 4. The goal is to find the longest subsequence such that the sum of every adjacent pair in the subsequence has the same parity, meaning the remainder when divided by 2e, either all even or all odd. A natural first step is to check if the entire array itself qualifies as a valid subsequence. Let's evaluate the sum of each pair. 1 plus 2 is equal to 3, which is odd. 2 plus 3 is equal to 5, which is odd. 3 plus 4 is equal to 7, which is also odd. Since all three adjacent sums are odd, the parity remains consistent throughout the sequence. Therefore, the entire array 1, 2, 3, 4 is a valid subsequence that satisfies the condition. As a result, the output for this test case is 4, which is the length of the full array. In this example, the input array is 1, 2, 1, 1, 2, 1, 2. To solve the problem, we need to identify the longest subsequence in which every pair of adjacent elements adds up to either always odd or always even. The parity of all these sums must match. At first glance, it may be tempting to assume that the entire array could qualify, but a closer look reveals a problem. Let's observe the sum of elements at each position. 1 plus 2 is equal to 3, it's odd. 2 plus 1 is equal to 3, it's odd. 1 plus 1 is equal to 2, it's even. Here the sequence breaks at 1 plus 1, which disrupts the consistent odd parity. To fix this and maintain a valid pattern, we need to skip one of the ones in the middle. The best way is to select the subsequence 1, 2, 1, 2, 1, 2, skipping the unnecessary one that causes the break. If we check the sums in this cleaned up sequence, 1 plus 2 is equal to 3, it's odd. 2 plus 1 is equal to 3, it's odd. 1 plus 2 is equal to 3, it's odd. 2 plus 1 is equal to 3, it's odd. 1 plus 2 is equal to 3, it's odd. All adjacent pairs sum to odd, so the pattern holds consistently. This gives us a valid subsequence of length 6, which is the longest possible for this input. Thus, the correct output is 6. Now let's talk about the logic behind our solution without diving straight into code. We track 4 key patterns while iterating through the array. All odd numbers only, since odd plus odd gives an even sum. All even numbers only, since even plus even also gives an even sum. Alternating even odd even. These produce odd sums. Alternating odd even odd also produce odd sums. For each number, we check if it's even or odd. If it's odd, we can extend the odd-only subsequence, or add it after an even to extend an alternating sequence. If it's even, we can extend the even-only subsequence, or add it after an odd for alternating parity. We dynamically update the best length of all 4 sequences during the loop, and finally we return the maximum among them. This approach works beautifully because it handles both even-only, odd-only, and alternating sequences all in one pass. Let's talk about performance. Time complexity is O(n). We just loop through the array once. Space complexity is O(1). We only use a few variables to track sequence lengths. This makes the solution super efficient, perfect for large input sizes. Here are some final takeaways. This problem is all about parity analysis, understanding when sums are even versus odd. A valid sequence can either have uniform parity, like all odd numbers, or alternating parity, like odd, even odd. By recognizing this pattern, we can design a single-pass greedy algorithm to track the longest valid sequence dynamically. It's a great example of how combining simple math with state tracking leads to an optimal solution. And that's a wrap, Shinobi. We cracked LeetCode 3201 by mastering parity patterns, and building an optimal one-pass solution. If this helped you, drop a like, subscribe, and hit that notification bell so you never miss a coding breakdown. Got questions or want a follow-up video on other similar patterns? Drop it in the comments. And as always, keep debugging, keep learning. This is BugNoJutsu. See you in the next one.